Let's talk about introducing data models. One of the things we need to understand before we get into how to build a model is why we would build a model. And so we want to talk about typical requirements in a business environment that might lead you toward designing and delivering a model. So let's talk about the kinds of things that users require, that users need, or that our enterprise needs, starting with queries. Peter?
Right, so foremost, the model is there to answer the questions that your users have.
Right. What about integration?
Bringing together multiple systems, so often the need to bring in financial data against operational data. And that extends to multiple subject areas. And so the more subject areas that you can include in your model, the richer the analysis that can be delivered.
Is performance going to be beneficial here?
This is one of the biggest selling points of a data model, Chris, and that is that representing large volumes of data. And let's bear in mind that our users are quite picky and they want high responsiveness when they ask these questions, and so therefore performance is key. Now, often the approach we take is that we import the data in the model so that the data is stored and cached and optimized for high performance delivery.
Now, if it's imported, that implies some kind of separation between the source data and the model. Can I accommodate low latency needs?
Right, so the cost of having the high performance is often achieved through caching, and the price you pay there is that your data is only as current as the last time you've processed. There is the ability, however, to deliver a pass-through model that allows you to query the model and then in turn your underlying data source is queried.
Sure. So one of the other things I'd like to be able to do is add custom calculations, to add custom business logic to the model so that I don't have to do it in the report.
Well, all that users want is the ease of drag and dropping a field that represents a calculation into the model.
And so if I can import the data into one place and put all the business logic into one place, that gets me one step closer to that idea of a single version of the truth.
In my opinion and experience, this is one of the most important things the model delivers, is this single version of the truth that says, let's define the logic in one place and then reuse it consistently across all types of reporting experiences. That way we don't end up with arguments about what does profit mean in this report versus this. If they're based on the same model,
Sure.
They're the same thing.
And that can extend then to scorecards and dashboards using KPIs.
Absolutely. So for consistent monitoring, often the need to compare what is actually happening to what is planned or forecast, we can deliver these as first-class objects within the model.
All right. I also want to be able to provide interactivity to my users. I want to be able to drill down, drill through, slice and dice.
Users absolutely love this. So slicing, dicing, the ability to drill through to details.
All right. And of course, we want to be able to include our users from all over the globe.
Right, so when the French employees connect to the same model, they'll see a data model that they can understand in terms of its structure.
Right, so the labels will be in French for them.
Absolutely.
Excellent, all right. And then of course, we like visualizations. We don't like tabular reports all the time.
Right, so it doesn't have to be just a tabular report. We could connect to this model, we could express it as scorecards, interactive reports, worksheet reporting.
Finally, I need to be secure. Can I get security out of a model?
And the model can do a great job of this if this is what you need. So right down to row level security, we could have all users connect to the same model, and yet depending on who they are, they'll see different data.
So let's go from this into where the model fits in our larger environment. So you and I both come from a more traditional data warehouse background. In fact, we put together our course, DAT 214, which was delivering a relational data warehouse here on edX, and we're going to add a layer now. So as we see on my slide, as I move from the left across, we start with our source systems. When we build our data warehouse, we've got our extract, transform, and load, or ETL layers, where we bring things into data marts or the data warehouse. We've redesigned into denormalized star schemas. Now what? We're going to add a layer for models.
Right, so all of this great design approach, tried and tested, these are the methods that are used today for enterprise delivery. We can see here where the data model is designed to fit in. So on top of these relational star schema designed systems, they do a great job. But what they don't do particularly well is expressing large volumes of data with high performance responsiveness. And all of those requirements that we've just detailed can be encapsulated into these models and delivered for end user access.